So yes, my name is Nicolas. I'm Chief Architect at SuperAwesome, and today I'm going to talk to you about how we run Druid on Spot instances and how you could potentially do the same. So I'm going to go through 4 different things. So I'm going to give you a really brief and quick overview. Then I will talk to you about our Druid setup to give you a little bit of context. And then we'll go through Spot instances and also some tips and tricks when running Druid on Spot instances. So the mission of SuperAwesome is to make the internet safer for kids. We started the company in 2013 and we've grown really rapidly since then. We recently got acquired by Epic Games, the company that's running Fortnite. And so usually everybody agrees that kids should be protected online and that people shouldn't collect personal data about them. But apparently we are the only ones, or at least the biggest ones, to do something about it. So we give companies tools to build apps and websites, monetize them, and engage with their audience without collecting any personal information. And in the rare cases when they actually need the information, for example, for a game like Pokemon Go that integrates us, and then we would enable them to get parental consent before collecting that data. So in terms of Druid, this is a pretty standard Druid setup. That picture actually comes from the Nick blog post. And in our case, we run Druid on Kubernetes. So we have a dedicated AWS account for our reporting, but we have a Kubernetes cluster where we run Druid. The users would access Druid through a load balancer. We would use S3 as deep storage, and we would store the metadata of the segments in MySQL. We index the data from Kafka, and all different Kafka clusters would actually be in other AWS accounts where we run our products. So whenever possible, we try to use infrastructure as code to set up our services. So outside of Kubernetes, we would use Terraform to set up the load balancers, the instances, the caches, the database, and of course, Kubernetes itself. And then inside Kubernetes, we will use Helm for infrastructure as code. We access all Kubernetes clusters using kubectl, and the authentication would be done using IAM, which is pretty so we use the default AWS tools rather than rolling out our own users. And then we use Kubernetes, EKS for Kubernetes, and 90 to 95% of our instances will be Spot instances. And that's what I'm here to talk to you about today. Okay, so let's dive a little bit into what Spot instances actually are. So when you start servers on AWS, you can choose 3 different ways of running them: on demand, reserved, or Spot. When you run them as on demand, you pay the full price, but you are sure that your server will be available. So you start a server and you will keep it basically forever until you decide to stop it. In some rare cases, AWS might shut it down, but they might give you really a lot of notice. And another advantage is that you pay only for what you use. So when you start a server, you start paying for it. When you stop it, you stop paying. This is a really flexible way of running things, and you can run basically any type of application on that. Then when you start becoming a heavier user, usually you would look at something like reserved instances. So it's kind of the same as on demand, but you would commit for a specific period of time. So 1 year to 3 years. So you would tell AWS, I want to use a server of this specific instance type for 1 year or 3 years, and they would give you discounts depending on for how long you commit and how much you pay upfront. The discount usually would be between 30 and 60%. If you commit to 3 years and pay everything upfront, it might be even slightly lower. So again, the server would be always available, but one of the main differences is that you pay even if you're not using the server. So if you start an instance of that specific instance type, it's covered by your reservation. If you don't run anything, you're paying anyway. And then the last way of running them is using Spot instances. So you get an even bigger discount And what you need to do is you actually bid for the instances that are unused on AWS. And then if you win, AWS gives you an instance that you can keep for a certain amount of time that is undefined. And you keep it usually until AWS decides to reclaim it for a reserve or on-demand instance. So you would be able to use those servers, but if a user somewhere on AWS would start an on-demand instance, AWS would decide to shut down your Spot instance and give them that server to start their on-demand instance. So the mechanism changed slightly over the years, but it still does. That's principle. When you bid for something, you can get some servers, and the main drawback is that you can lose them at any time with 2 minutes notice. So usually you would run on Spot instances only applications that can support interruptions. But in our case, we decided to run most of our workloads, including Druid, on Spot instances. And I'm going to walk you through why it works for us and why it's important for us to actually make it work. So this is a breakdown of our AWS cost for Druid. So I basically went through the AWS console, look at the breakdown of the cost for that specific account. So a tiny percentage of the cost of our Druid setup goes to the database. Then we have S3, so the deep storage segments. And then the vast majority of it, 60 to 80% if you count the local storage, the EVS volumes, would be going to the instances. So this is using Spot instances. So if I take the same costs and look at how much it would cost if we were not using Spot instances, I get to this, right? So if we were running the same Spot instances on demand, we would be paying almost 3 times as much. Or another way to see it is that we are saving 60% of hosting, more than 60% of hosting cost by using Spot instances. So on one side, you have that issue that you can lose the instances on short notice. And on the other side, you have that massive advantage that you save a lot of money. So let's look a little bit at Druid and where it stores its data. And that's going to help us understand why we can run Druid on Spot instances. So we index our data from Kafka. So Kafka would be the source of truth for the data that hasn't been indexed yet, or the data that is currently being indexed and hasn't been persisted yet. So we run those Kafka clusters on MSK, which is the hosting service from Amazon for Kafka. So that would be outside of our Druid cluster. And then the 2 other sources of truth would be the deep storage, so where the segments are saved once the data has been indexed, and the segment metadata, which is basically gonna tell Druid which segments exist, which data sources exist, how to index the data, and what data should be loaded. And all these are stored outside Druid. So inside Druid, nothing is actually the source of truth. Let's go through a few Druid services, and I'm going to explain what that actually means. So some of the Druid services store data only or mainly in memory. So you have the broker, the coordinator, and the overload. So if you were to restart these, you would lose the data that's in memory, but it wouldn't really be a problem because that would just re-register with the rest of the cluster, and they would function normally. And then you have another set of services that actually store data on disk. So Zookeeper can be destroyed, and that won't affect Druid because Zookeeper, like the data kept in Zookeeper, it's only about auto discovery and the metadata of some segments, but it's not the source of truth for it. So if you delete Zookeeper, empty the disk and start it again, Druid will actually self-heal and auto-recover. For the historical nodes, the historicals save the segments on disk, but they are the source of truth for the segment. So if you, again, if you stop an historical node, empty its disk and restart it, it might take a few minutes for the cluster to understand that it has restarted. It might load another set of segments, but it won't lose any data because the source of truth is S3. And it's also the same for the middle managers, because the middle managers would store the data before it has been actually saved into a segment. And then at that point in time, the source of truth is Kafka. And once the segment has been saved, the source of truth would become the deep storage and the segment metadata. Okay, so this is under normal Druid operations. So that's, if you assume that you have some segments and then data has been indexed, and you know that you can at any point in time delete any Druid service, including its data on disk, and that Druid will recover. But there's another thing to take into account, which is the indexing. I think one of the things that people don't often realize about Druid is that it has that exactly once ingestion guarantee. It means that all your data from your data source like Kafka and another one on AWS will be indexed once and only once into Druid, regardless of whether you kill Druid services in the middle. So let's look at how it's done. So when you start indexing, the overload will start some indexing task on the middle manager, and those tasks will pull data from Kafka. Your task would run for a certain amount of time. In our case, it's 1 hour. And then at the end of that time period, you would have a handover process. So I'm not a Druid expert, so I might get some details of that wrong, but my understanding is that it works the following way. At the end of the indexing task, middle manager would save the segment into S3, so in deep storage. And once it has been done, it would update the segment metadata to tell Druid that a new segment exists and that it should be loaded. Once the segment has been loaded onto a historical node, the indexing task becomes basically redundant because the data is already present on the historical, so it can be safely shut down. So if you lose your task before number 2, so when you are doing the indexing and when saving to S3, you are not actually losing any data because you can simply start the same task again. And you know that it's going to pull the exact same data from Kafka and index it. If you lose your task after that second step, so once the segment metadata has been updated, then you know that Druid will recover because the historical will load the segments, even if the indexing task doesn't exist. So then the question becomes, what happens in 2? One extra thing to understand about that is how Kafka offsets are stored into Druid. So by default, when you have a Kafka consumer, so outside the context of Druid, the progress of the consumers would be stored in Kafka. So you can see that can cause an issue, because if the progress of the indexing task is stored here and the state of the segment is stored here, you could be get in a situation where one has been updated and not the other. But in the case of Druid stores its offsets into that segment metadata database, which means that Druid can be told at the same time that the segment exists and that the data has been indexed. So I didn't actually check the code to double check that it's true, but I expect Druid here to do that update in one database transaction, which means that it would be atomic. Either Druid would understand that the segment exists and that the data has been indexed, or none of it would happen and the data would simply be reindexed. Okay, so we looked at the Druid services and how it's okay to restart them. We looked at the indexing and look at why it's also okay to restart them to kill things around. But then we also need to worry about availability, and we need to make sure that even if we lose anything in the cluster, we can still access all the data at any point in time. So the places we need to look at for that are the middle managers and the historicals, simply because those are the ones that store the segments. So in the middle managers, if you look at your indexing task, you will notice that the index of the task is split in two. The first part is what's called the availability group, and then the second part is the index of the task. So when you ask Druid to create more than one copy of an indexing task, they would have different index, well, different task names, so the second part of the name, but they would be in the same availability group. And Druid would run tasks from the same availability group on different middle managers. It means that if you're indexing the same data twice in two different tasks and you lose one middle manager, the data will still be indexed and will still be available on that other task. And in the historicals, you have something similar. So you can configure Druid to keep more than one copy of the data on the historical nodes. And those different copies of the segments will be spread across different historical nodes, so that if you lose one historical node, you can still query all the data. Okay, so that guarantees that if you lose one, you can still query your data. But then we also need to look at how fast Druid can recover when one of those events happen. So I mentioned earlier that you could stop Druid services, clean the disk, and restart them, and that it would work. So it's good to know, but in practice, you would attach a disk to your middle managers or to your historical nodes. So what would happen on the historicals when you start the historical node and there's already some data on the disk, is that Druid would read that data and it would basically load all the segments that are already on disk before registering itself with the coordinator. So it means that if you restart a historical node, you might, for a very short period of time, the coordinator won't be sure that the node is going to come back online. It might think that it needs to rebalance the data, or it might even start doing it. But if the historical node comes back online really quickly, then it will tell the coordinator that it already has the data, and Druid will recover very quickly. It's the same for the middle managers. So I mentioned earlier that those tasks often last for 1 hour, but during that hour, Druid regularly persists the data on disk, so that if you kill a middle manager, when it will restart, it will look at the data that is already on disk. It will load those partially created segments. It will announce that it has them, and it will continue indexing from where it stops. Right. So this guarantees us that if we kill anything, Druid will recover quickly. Okay, so we run Druid, and we have that extremely low chance of interruption. And when we get interrupted, we know we won't lose any data, and we know that Druid will recover quickly. We are still being a little bit careful outside of Druid. So we query Druid in many different ways, but the two main ones are using a real-time decisioning engine for our ad server and the reporting API. So for the real-time decisioning, We wanted to make sure that it would still work even if Druid was down. So when that real-time decisioning process starts, it basically queries the data from Druid, stores that into memory, and then it reads the updated data from Kafka. So in a way, we keep a very quick count of how many ad impressions we have served so far during that day. So that even if Druid goes down, we know that we are not at risk of stopping delivery or over-delivering, because in both cases, we would be losing money. And for the other type of clients, if we get any error from Druid, we would simply retry the request. So we get to tips and tricks. So one of the ones that really helped us in a previous version of Druid is to create some DNS records for the different Druid services. So in our case, because we run Druid on Kubernetes, when we restart a Druid service, it actually changes IP. And when we were testing the behavior on spot instances and how tasks were restarting, we noticed that when we were killing a middle manager, it would restart, but the overload would wait for a certain period of time before seeing that the old middle manager had disappeared, and then it would reschedule the task on the one that had just restarted. So it means things worked, but they were very slow and things were delayed because the behavior we wanted was to restart the existing indexing task. So we solved that by having some internal DNS records that are actually managed by Kubernetes, so that when the middle managers start, it would register itself with the overload using the DNS name. So if we replace them and they change IP, the DNS name would still be the same, and Druid would understand that that middle manager is supposed to have some task cached on disk. So we set that up on an earlier version of Druid, a really old one actually. So I'm not sure that it's still necessary now, but that's good to know if that's still the case. Another one is to use the Spot Instance Advisor. So as I said earlier, you can lose your instances on short notice. You can get a 2 minutes notice from AWS. And even though we know that Druid will work in all cases, we want to minimize the number of interruptions. So AWS has a tool that allows you to see how likely you are to lose spot instances. So it gives you the frequency of interruptions over the previous month. So 5% would more or less mean that you would keep your instances on average for 20 days. And 20% would mean that you would keep them on average for 5 days. In practice, it's not evenly distributed. So when you have a low frequency of interruption, you could keep instances for a really long period of time. When the frequency of interruption is really high, you might constantly lose your spot instances. So looking at this and looking at instances that have a low frequency of interruption is really, really important. And it's okay here to use slightly suboptimal instances or older generation because the cost of running one more historical or one more middle manager because you're running using older hardware is offset by the cost benefit. This is an example of for how long we keep our spot instances. So I went yesterday on the AWS console and took a screenshot of this. So we are in October 2020. You can see that on that account, we have a spot instance that was started in February, so 8 months ago, and others over the summer, so 3 to 4 months ago. Another good trick is to use the AWS spot termination handler. So I said that you get that 2 minutes warning from AWS. You can actually respond to that warning directly from the instance. You can listen for it. and perform some actions. In our case, because we run it on Kubernetes, we would do what's called cordoning the node, which is making sure no new pods get scheduled on it. And we would start rescheduling the pod, which is basically moving the containers to other EC2 instances. The effect of that is that if we need extra servers to relocate the nodes, we would start them from the moment we get that warning rather than from the moment we lose the instance. Another good trick is to monitor what's called the ingestion lag. So if you think about Kafka and the way it stores the data in topics and partitions, typically you would have produced data up to a certain point in the topic, and you would have consumed it up to another position. And the difference between those 2 points is called the Kafka lag, and in the case of Druid, then the ingestion lag. It's important to monitor that because it tells you if your ingestion tasks are falling behind. It's not fully related to spot instances, but it's a good tip. So on a healthy cluster, the lag would be very close to 0 most of the time, and it would occasionally spike if there is a bit of delay in the system. But most of the time, it would be very close to 0. Okay, so one last thing I wanted to mention is chaos engineering. So when you run some systems, you need to make sure that they can handle interruptions or unexpected events. So there's that idea that you can do some chaos engineering to delete your services, use something like Chaos Monkey to ensure that you would handle these situations. But in our case, because we use spot instances, we have that built into the system in a way. We don't need an extra tool to do that. Because we use spot instances, we know that we will lose servers at any point in time. So whenever a service has any availability issue, we detect that quite quickly. And another interesting side effect of using Druid on spot instances and doing that chaos engineering is that your deployments will be easier because you can see like the effect of losing a spot instance and the effect of upgrading Druid or restarting some services. It's exactly the same. You will need to restart some processes and potentially relocate them to other places. So if you're ready to handle spot instances, your deployments will be easier because your services will already be ready for interruptions. So in our case, if we look at all the Druid services that we have on Kubernetes, we would be able to delete all of them, including the disk, restart Druid, and we have the confidence that the system would come back to a stable state with all the data being loaded. I think if you are running Druid, you should look at your system and wonder whether you could do the same. So basically, would you dare deleting all your Druid instances, and would the system recover? So of course, don't do that if you're not sure, and don't blame me if you do it, if you lose some data, please. Okay, so to summarize, everything needed to run Druid on spot instances is already built into it. So you only need to understand bits and pieces of it, like why it's okay to restart the services, the exactly one's ingestion guarantee, the redundancy of the tasks, and the redundancy of the segments on the historical, and how you can make sure that it restarts quickly. But everything is already there. Also, you need to remember that you won't actually lose any data if you run Druid on spot instances, because the data would be either in Kafka, deep storage, or the metadata store. So I think it's true for Kafka, it's true for Kinesis. In the really old Tranquility setup, I think didn't have that guarantee, but with Kafka and Kinesis, you have it. And also, even though it's you will need to handle more things and think about all the consequences of using spot instances. In most cases, it will be worth it financially. In our case, as you probably saw, we saved quite a lot of money doing that. So it's definitely worth the time. Thanks.
Brilliant, Nicolas, thank you.
Does anyone have any
questions? Any questions? We still have like about 10 minutes.
I have a question, if I might. So have you ever noticed that the AWS would kill the instance, the spot instance, without any prior notification?
We haven't noticed that, and it is in the AWS documentation that you would get that 2 minutes warning. So it's the way you need to listen for it is some metadata service on AWS. And it's an endpoint that you can pull, and AWS recommends to pull it every 5 seconds, I think. So we haven't noticed that now.
Okay, thank you.
Hey, Nicolas, it looks like Peter Marshall has a question for you in chat. Is the spot notification handling something that's handled automatically, or is it fully manual?
So in the case, so it's manual in the sense that the EC2 instances don't handle it by default. You need to add something to handle it. But in our case with Kubernetes, we simply deploy one that's called a daemon set that would run on every instance and handle it for us. So yes, you need to handle it manually, but you would not need to create custom code. You should be able to reuse some kind of existing service. Like many people use spot instances. So usually on the different container orchestration systems, you would always have some pre-built service that would do that for you. Does that answer your question? So yes, you need to think about it, but now you don't need to create custom code. Let me know if you have more questions. You can also ping me on LinkedIn later if you prefer.
Okay, fantastic talk, Nicolas. Thank you. We'll be looking forward to sending out the recording to everyone so you can share it with colleagues and also with anyone who missed the talk. Next up, we have Peter Marshall. He is the technology evangelist at Imply. Welcome, Peter. I will hand it over to you.
Cool, thank you. I loved that talk, Nicolas. Thank you very much. It was really great. Okay, can people see my screen okay? Thumbs up. Am I seeing thumbs up? Yes, good. Okay, so mine won't be as exciting as yours, Nicolas, I don't think, but what I'm going to run through today is just some general tips and tricks of using Druid, of early adoption of Druid. Hopefully it'll be helpful for you. Let's see. So first of all, a little bit about me. For those of you who don't know who I am by reputation, my name is Peter Marshall. I'm an Apache Druid technology evangelist at Imply. I've got 20 years enterprise architecture experience for my sins, and I've got a BA in theology. But as I always say, please don't ask me questions about God unless we're drinking. I collect books, which means they sit on my shelf and I don't read them. My contact details are on there, but please reach out to me if you've got any questions about anything that I say or any suggestions either. So today I'm going to just highlight some of the issues that have come up in the community, talk a little bit about those, what the priority issues are, then run through some tips and tricks that I've picked up over my time working with Druid, which is about 18, 19 months. And then no presentation is any good without a call to action. So there's a call to action in here, and then there's a time at the end for questions and answers. And I hope you're all sitting comfortably and you've got a cup of tea, because this is going to be a little bit of a sprint. So, are we ready? Here we go. This is my team at Imply. Jelena, we've just seen a moment ago. She is a coordinator, senior community manager. She's in contact with people across the world in different meetup groups, whether that's Imply meetup groups or general meetup groups, and working with speakers across the community. Rachel Podreski is a self-confessed data addict. She is amazing as a speaker. Go and look at stuff that she's done. She's worked in a whole range of different companies and is now with Imply talking about Druid. Matt Sorrell, another amazing writer. He's just published a blog working with Liquid M. That's great. Have a good look at that blog. And then there's me, the good looking one. I am supposedly a writer and good speaker. I don't know. But I am definitely an ex-solution architect, and please don't hold it against me, I used to work in pre-sales. If you're at the start of your adoption journey, if you've got questions or you run into problems, we as a team are here to help you get unstuck if you're doing POCs, if you're doing initial research, just being innovative and thinking about what you're going to do with Druid. We also write slideware, of which mine is always the best, obviously. We do blog posts. We've got an eye on the community, seeing what other people have written and promoting that on Twitter and in LinkedIn. And we're always looking for people to help write and contribute new content. Many of Imply's engineers in the software development team are committers, PMC members. And we kind of try to keep those people up to date on the kind of issues that people are facing, letting them know what code and documentation people are asking for, but also we share that back with people in the community. We also trying to bring people together. We were reminiscing about the last time we got together and ate pizza earlier. Doesn't that seem like a long time ago? But lots of things like the virtual meetups we're having today, and trying to encourage people to post about where you can go to meet each other, where you can go to exchange tips and tricks, where the best practices are, and helping people tell their story about Druid. So this is what the team's about. So when somebody said to me, why don't you speak to people about the kind of issues that people have with Druid and how to do tips and tricks, I thought, well, what a brilliant idea. I'll go and talk about the POCs that I did at Imply. And how it would be great, and people would learn lots about the issues I had during sales, and what my customer success team colleagues know in Imply and what the support function needed. And then I had a bit of a guilty conscience, and I thought that's a ridiculous thing to do, because us in the team are members of Slack and of Google user groups and of Stack Overflow, and we're involved in the Druid summits, and we've got lots of information between us about what it is that people in the community are actually having problems with, i.e. data. And that data tells us what you're saying about Druid. It says what common problems are, what the day-to-day operational issues are, and we're kind of using that ourselves as a team, as members of the community, to work out what we should write, what kind of docs updates might be required, what code changes might be required. And yes, we're also looking for arch druids, i.e. the really clever ones out there, like Nicolas and Seidul, who we heard from earlier, and people who speak at Virtual Druid Summit, those people who know a lot more about Druid than I do. So I thought, well, I used to work with some really cool people who work in support. How would they categorize the issues? How would they say what the big problems are? And as a team, we came up with these 5 areas. So any questions or issues that people have, they're raising on those channels, we bucket into one of the 5. Design is anything that's to do with the data pipeline, the building blocks, and people trying to work out how they're going to realize those services, how much data is going to go through, what size and shape it is, and how frequently that data is going to pass through the pipeline. Secondly, anything where people have got questions about deployment, whether that's done manually or whether it's done through some kind of automation, how they configure network services, how they do the routing, what the firewall configuration needs to be, how the hell they put encryption certificates onto the different processes, and what the 3 Druid dependencies are: deep storage, zookeeper, and metadatabase. What services should they use for those? Then we have this 3rd box, which is anything to do with how people are actually using Druid. And what we notice, I guess the first thing to say is that that is iterative. Every single person that we speak to does it iteratively. Sometimes they don't realize that to start with. They soon do. When you're doing your stuff with Druid, you are going to start and then keep iterating, and it's going to keep going and going and going. It's a very agile tool to use. Fourthly, questions about how people harden it. I don't just mean security hardening, I mean performance hardening. I mean understanding what the SLAs you can achieve are, what kind of training you might need to provide to the people who are going to receive the thing that you're building. Anybody who is ITIL qualified, if I say to you service transition, that's what I mean. And then in the fifth box, anything to do with monitoring and supporting and maintaining the system, upgrades, etc. Now the create box, we thought that's a little bit too little detail. So we've broken the create box down into 3 areas, into ingestion, query, and database management. Those of you who are familiar with Druid will know that we are talking about the 3 lead processes in a Druid cluster. Ingestion, led by the overlord. Database management tasks, led by the coordinator. And then querying, led by the broker. And when I say it like that, I think those of you who are Druid users will understand what I'm talking about. Defining the ingestion task and submitting that, working out what the schema is, any parsing rules, transformations, filters, connectivity, any tuning options for the specific ingestion source you're going to, how the execution works for the ingestion, and making sure that that's performant. Database management, anything to do with the assignment and balance of the data throughout the cluster, including targets for automatic compaction, and using the metadata services to reshape and to understand how you should heat and cool your data. And of course, the famous kill task. And then when the stuff that's led by the broker, how you design the queries, how you get the queries to execute, and how you apply security. And when we looked at the data, we found that by far people have the most issues with ingestion. And secondly, with designing and executing queries. And tied in third place are questions in problems with maintaining the database behind Druid and issues with deployment. Now, Ella and I work for a data company. So when we shared this information internally, they said, but we think we probably need more detail than that. So Matt and myself and Rachel and the other went back to Slack and Google user groups and to Stack Overflow, and we subcategorized the things that you guys have been talking about into even more categories. Ingestion, we broke it down into people having problems writing the specs, people executing the ingestion, people having problems connecting to the, you can see where this is going, right? We really went down into detail. And when we did that, we found something interesting. Nearly half of the questions and problems that people face are to do with actual ingestion of data into Druid. Half of that relates to how ingestion actually executes, i.e. the processes that run the ingestion jobs, the stages they go through, especially understanding what the errors themselves mean and how to solve them. And the remaining portion you see here in yellow has anything to do with how the ingestion is actually specified, how you write an ingestion spec. And then the remainder is to do with integration to back-end systems. So all of this might be no surprise to you whatsoever. You may have felt like this for a very long time, but now there's data, you see, and you know how important data is. So today I've chosen to prioritize passing on tips that I think particularly are about ingestion. But I'm also appealing to you guys here today and you guys watching the videos across the world, really think about getting busy and writing and talking more within the community, and also for people who are just adopting Druid about ingestion. So here's just some examples of the kind of things people have been asking. This is actually back from August. Things like, I love this one at the bottom, I don't know why. Ingestion was throttled for 35,610 milliseconds because persists were pending. These are some to do with people having issues actually writing their ingestion specifications. And if you're finding yourself thinking, well, I know how to answer all of that, that's really obvious, I've had that problem. Please think about coming into the channels, writing blog posts, proposing updates to the docs, giving presentations, etc., that are going to help other people solve these problems for themselves. So let's get on to the actual tips from Peter Marshall, and you can vote as to how brilliant these are or how terrible they are as we go through. Don't walk alone. Work with end users to sketch out what your Druid-powered user interface is going to like. I can't emphasize this enough. Think about, as soon as you feel that early tingling in your toes that says, wow, Druid is awesome, and I know that happens all the time, speak to your product owners. Ask them what dimensions they need, what their common filters are. Could they use rope? What are the performance requirements? Is it different on one visual to another one? Are there going to be interactive elements, or is it quite static? Why would you ask this? You ask this because it better informs your ingestion specification in all areas. The dimensions you need, any transforms and filters, any roll-up metrics you can create, whether you should use tiering. And never, ever forget to test the water with about approximations. Ask them directly whether an approximate distinct count is good enough for trend analysis, because in most of the cases, most of the examples I've seen, it usually is. Further back in the pipeline, it also helps the pipeline design. It'll open up questions of whether you need to enrich data before it hits Druid, or whether you can safely do it inside Druid. Message here is, think about the end user. Druid is that database that is just before the user application. Avoid doing a POC at all costs, please. Chucking everything in and then hoping for the best. Here's some just basic tips when it comes to like designing the user interface you're going to build or plug into Druid. Real-time data analysis starts with time as a key dimension. Business intelligence tools don't often focus on time. Business intelligence-led decision-making doesn't often focus on time, but time is central to Druid. So think, how would I incorporate timeline visualizations? How would I filter the data based on time? How will I sort my results according to time? Will I bucket things according to time? Comparisons make people think differently. So given what we said about time, let people use the whole of their brain. Instinctive and considered thinking. Don't just provide them with today's data. Don't just provide them with last month's data or a month's worth of data. Think about what your user interface would look like if it showed not just today's spend, but also at the same time last week's spend. Filters make one visual cover multiple contexts. So with filters on your visualization, you encourage people to explore the data. Some BI tools just don't do that very well on large data sets. And often when we've got pre-computation in the pipeline, we're kind of used to just filtering things early. Measures make one visual cover multiple indicators. Druid allows you to quickly generate multiple measures and aggregates on the same underlying data, and that frees your users from the kind of issues you'll have had in the past with not being able to get measures generated quickly enough, whether you're building a cube or whether you're doing pre-computation. And if the filter and the sorts and the group bys on a query are the same, it's actually very efficient to ask Druid to give you multiple measures in just one query. It's having to scan that segment just once rather than multiple times. Create data sources that are focused on speed. It's very common for Druid builders to have multiple data sources, with some that are red hot lava with critical dimensions, approximation, roll up, filtering at ingestion time, to create this data source that's amazingly, blisteringly fast. And then they'll have another one that's slightly more cool and a little bit more laid back. And that data source will have probably more dimensions, finer granularity. It might even have raw data, but it's generally accepted. It's a little bit less performant. And finally, create magic with Druid. Druid lets you create some really cool interfaces that will differentiate you in your team and also your company from the competition. So take a look on the web. People like Game Analytics. This is their amazing, cool looking interface they've built on top of Druid. Have a look at their virtual Druid Summit talk. And Polefish, there's a blog post just being put onto the Imply blog about what they're doing here. This is all ad tech survey response information, and it's just cool to look at and to use. Next one, try not to create superheroes. Try not to create an individual in your company who is the only person who knows everything about Druid. It is dangerous. Think about sharing that knowledge and creating a self-organizing team, one that wants to learn every single aspect of Druid. It may be break it down into those different stages, but think about sharing the knowledge. Don't create a superhero. Next, Druid is not an island. Druid has to exist in an ecosystem. It has service and infrastructure dependencies. Speak to architects early about how you might deploy it, about whether you can deploy it. It could be, how do I get my network ports open to my HDX cluster on GCP when actually I'm running Druid on AWS? Or it could be that I've got it running in a different account on AWS to where my Kafka stream is coming from. More and more we see people using Kubernetes. It seems to be becoming the de facto way of deploying everything from Druid to a potato salad. If you're hot on Docker, remember your network engineer may not be. And at that point, when you can't figure out why Kafka won't ingest, or you can't write segments to the deep store, if it's a network issue, you could be stuck on your own. It itself has dependencies, and Nicolas was just talking about. We've got a blob store, a relational database, and Zookeeper. Take care to know performance and their capacity, and also their longevity and their supportability inside your organization. This slide is from a post by FJ Fanjin Yang called The Big Data Zoo. As an ex-architect, I can tell you a diagram like this that explains where Druid fits. You would have made me a very happy person. Give them the post. You can scan that barcode at the top left-hand corner there. Give them that and let them read about where Druid fits and what it does. Next tip, jump right in. Okay, don't do that. The quick start is fantastic in Druid. Loads of work has been done for you, especially the configuration of the JREs. I see a lot of people having issues because they haven't provided enough heap, for example, or because they've specified lots of heap, but they're running it on a server with 3 tiny mice for memory. Heap sizing is particularly important if you're going to use lookups. Take a look at the tuning and configuration docs for Druid. There are formulas in there that will help you determine the right heap sizes, as well as some recommended JRE options, and go and ask in the community channels about heap. This is my personal hit list of things that I make sure that I configure when I'm using Druid. There are bound to be others. Just 3 I would call out here. The first is those settings relating to HTTP and to the pooling. That's often missed. Those limit the number of queries that the broker can issue and fan out when queries execute, and also the number of queries that the middle managers and historicals will try to process at once. Secondly, Druid worker capacity. The number of times that people don't realize they need to change that setting so that they can run multiple ingestion jobs at once on a middle manager. Please make a look at that. Another surprising one, Druid server max size. It's very common for people to not use all the local disk storage that they have available when they set up cluster configuration. And also remember that historicals will memory map segments as they are queried. So do think about the ratio of local disk storage to available memory. Next, stay connected. Druid is a distributed system. The query, assignment, and balance and ingestion work are all distributed. It relies on good inter-process communication. So monitor network traffic. Try to keep the network and the processes healthy, especially Zookeeper. What you don't want is to run into an issue where Zookeeper is running out of memory and it crashes and there's nobody there to help you fix it, or even to tell you that it happened. Know the team. Druid is not one massive process you install from a CD and press next loads of times. It's done like that on purpose. As Nicolas was saying, it makes it, because it's loosely coupled, it makes it highly scalable, it makes it highly resilient. These 3 processes, the overlord, the broker, and the coordinator, bring together all those things you're provisioning on your infrastructure in a very, very fast collaboration. I did a talk on this for the Bucharest Data Meetup very recently. If you'd like to get that off me, then please email me and I'll send it over to you. Love your logs. Anyone who spends time in the channels will see that people are always asking people to send their logs. It's not because we're all Ren and Stimpy addicts. It's because the logging in Druid is extremely detailed. From the start to the finish of every ingestion job, there is a detailed audit of every single action taken. Do you remember that Wikipedia sample data loaded when you did the quick start? Well, like me, you probably didn't look at the logs or read them. You didn't try and understand what they were telling you about what happened. And we're all guilty of that. We want to rush ahead and start building cool things on top of Druid. But take a different road. When you go back to your Druid cluster tomorrow or later today, or if you're just starting out with Druid, open up the log folder, take a look, read through some of the logs, and just spend a bit of time understanding what Druid is doing for you. And then when you have an issue in the future, you're much more likely to be able to understand what could have caused that blip and at what point it failed. Now, we are thinking internally about the content that we could write, whether that's something like a flow diagram or maybe an analysis of the logs. Or but if you've got any ideas, please write. Speak to us. We'll help you if you want us to. Please write about the logs in Druid. Keep it simple, stupid. I hate people that used to say this to me, but in this case, I would like to say it to everybody else. Druid is a sports car. Now, much as I really would like a Nissan GTR, one day, hopefully I will buy it, it will be really stupid of me if I drive it to the shops at 9.5 billion miles an hour. And it will be such a disappointment for me and a waste of my time if I get behind the wheel and I think I'm going to get the most out of it, only to find out that I crash out because I didn't go on the track first, I didn't learn the track, and I didn't learn about the car. When you're working with Druid, I highly recommend keeping it simple first. Start with a small, discrete, well-known data set, and then you can watch this ballet of the different parts of Druid working fantastically, and then hone and tune each one iteratively, work up to that goal. Maybe don't do transformations first, maybe don't do roll-up first. So on the left-hand side is just the kind of process that I used to go through. I used to work out what my target query list, what my top 10 queries are that I wanted to design for. I used to look at the source data columns and work out which ones I want to use at ingestion time for something like filtering or lookups or transformations. And then which ones my source in my query were going to be used for filtering, for sorting, calculations, for groups, buys, for bucketing, for aggregations. And then I'd set up my dimension specs specifically for those columns and for those queries, execute them. And if I was feeling really very good, I'd record the query performance as well and watch that change and monitor that. Then feel free, go and explore what other queries you could do with that data, but focus on what the end user wants first. Think about that communication with the product owner. Then add more subtasks, monitor the payloads for each of the subtasks that are being created, and keep checking the lag. Then add more data. I would recommend not throwing 500 gigs worth of Kafka events at it on day one. Some tips, use ingestion time filters. That helps you manage your segment sizes. If someone is 95% of the time always filtering on a particular field, consider either filtering it completely out of the data set and applying that at ingestion time, or creating those two different data sources. Use transforms to replace or create data so that if people are always asking for the same kind of calculations, do those as a transformation at ingestion time as an extra column. And carefully use the time granularity, so that's the granularity, and also roll up to generate metrics that people are always asking for, and to create data sketches for that important approximation. digest the specifics of the ingestion specs. The docs tell you how this spec breaks down. It tells you it's got data schema, it tells you it's got IO config and tuning config. Each of those parts has got critical configuration, whether that's basics like the specific type of the dimension you're going to ingest, or whether it's something complicated like how you're going to subpartition your data. So I would recommend when you're building this ingestion specification, it's really worth spending time looking at each part of the ingestion spec in turn, starting simple, and then uncovering all of the options you have. You might spend some time doing exploration on what each of the options do for you, not just whether it works, but how changing a particular option affects the data that it ends up inside Druid, and almost more importantly, how it affects your end user experience, what they can query, at what speed they get those queries. Understand segments. Ingestion is where data is sharded. It's sharded by configuration in the specification. It really is worth checking that the ingestion specification you've written is creating segments of an optimal size and content, and clearly understanding all the levers you have that affect that. We need to take care of the cost associated with historicals. We need to scale out the historicals with the right balance of storage and compute according to performance requirements for the data we have inside Druid. Secondly, we mustn't let the Druid deep storage grow and grow for no reason. We need to keep careful control of the infrastructure costs that come with that storage area in Druid. And thirdly, you must remember that each parallel query task that the broker issues, that fan out, will read one segment each per core. If one segment is too big, or worse, if all of them are too big, queries are going to take too long to run. And at the other end of the scale, if they're too small, then you're going to create this huge overhead in processors and in memory on the historical servers. All those threads become consumed with lots of tasks that each process only a very small amount of data. And that's why auto compaction exists in the first place, why it was designed. That means you've got to control both the count of the segments, as that affects the memory overhead and the processing power and the fan out, and you need to control the size of the segments, not just to control the storage costs, but also because size affects query performance. So more tips and tricks for you. Filter wisely. Think about what dimensions you need. Think about different segment granularities and different row maximums, because that controls the number of segments generated during ingestion. Use time bucketing widely and roll up wisely. I've seen people who have been getting 100:1 ratios and still being able to fulfill what the end users require. Think about tiering. Use drop and load rules effectively. Don't just think about indexing once. Think about how you're going to re-index the data later. Do you need to shrink it and make it less granular? Do you need to strip out some dimensions that people aren't going to use anymore? Never forget compaction. Peter Marshall, I don't know if you've heard of him, has often forgotten about compaction and left it too late. And it was a big mistake, because then I just create a huge headache for myself in having to compact segments later. Think about doing it either manually or through the auto compaction feature early. Keep those segments the right size. And finally, check the persistence of the data. That's several bits there for local persistence during ingestion, and then persistence to deep storage as well. Think about how big those segments are being created. Ask people in the community. They will have had the same problem as you. And if you're just starting to use Druid, ask us early. Do it in your design phase. Someone in the world will be doing the same data domain as you. They might be building the same application of you. They're likely to be connecting the same BI tool as you. They might even be doing the same kind of ML as you. There are lots of videos online. The Druid Virtual Summit videos are awesome because I presented them all. No, I didn't. I introduced them all. I didn't present them all. There's lots and lots of blogs out there. If you need assistance, if you've got questions, if you're facing problems, anything operational, join in the conversation. There's ASF Slack, Google User Groups, and Stack Overflow. If you want to meet people, not face-to-face at the moment, then go and look in Meetup. Yelena is looking after all of the Imply Meetup posts. You find all the stuff that Imply is sponsoring, but there's also independent meetups as well. And of course, Virtual Druid Sun. If you just want announcements, there's a LinkedIn group called Apache Druid. We're on Apache Druid. Go and look at Twitter. My Twitter feed is hilarious. Go and follow that. If you're a writer and you're thinking about writing your own guidance or recipes around ingestion or around particular data domains and good schema design, anything like that, please publish it and let us know, or come to us and we'll help you write that blog. Email community@imply.io. We also do 5-minute interviews like the Community Spotlight posts. We'll write those and help you talk about ingestion or anything else. Get meta. Druid emits all kinds of event data in its metrics, and it is event data. It's time series data. We're all using time series data inside Druid to help the business. Ingest that data as time series data and help yourself as well. Whether you're going to push it into Kafka or Prometheus or Grafana, do something with them. Some people even go as far as having JMeter jobs that run regularly that will look at the query performance as each ingestion specification goes through each iteration, so they can compare how the ingestion spec is affecting query performance. Some people even go as far as to use flame graphs, which look very pretty to me, and I don't really understand all of them, but flame graphs using Swiss Java knife, and they find exactly what's happening at the very lowest levels. If you feel like that, there is an article. This is the kind of thing that Imply Clarity, shameless plug, allows you to view and explore. These are all metrics that are coming out of Druid. The important ones are 98th percentile query times. That means most people are getting that query response rate. Query IDs, they're extremely useful. They allow you to do overtime comparisons of the same query. You can set that programmatically. Keep an eye on the GC time, and the total GC is important not just for the query execution, but especially for ingestion. That indicates that you've got heap size issues. Kafka lag, as Nicolas was just saying, indicative of lots of issues in the pipeline, let alone just within Druid. And the subquery count, segment scanned, and segment scan time all lead you to question whether your segments are optimized for the types of queries that are executing. And remember, those segments are generated at ingestion time, and you should think about comparing them. Here's Imply Clarity. So this is like for operational teams. This is the kind of views that are really important, really helpful for me when I was in pre-sales engineering, to understand whether we've got infrastructure issues, to understand how people are using the application and how they're building the end user experience, what they're using it for, and to keep an eye on that all important health of that ingestion. So, coming to the end, Druid is a community project. I'm part of it. Matt is part of it. Yelena's part of it. The engineers at Imply are part of it. You guys are all part of it. Ingestion is a significant challenge for everyone. Here's some ways you can help. Come with us, join us. I'm looking for people who've used to play Dungeon Keeper. This is, of course, a reference to the scavenger room. Join ASF Slack, join the Google user groups, say hello, give people emoji-based hugs. I do recommend that if you do ask for help or you point people to other sources of information, make that link back to source material. That really helps create this knowledge network across the world around Druid. Secondly, tippy-tappy-typey type, by which I mean, of course, please blog helpful hints and tricks and walkthroughs of your own ingestion integrations, of the specifications you're using, if you can, of how you configured the execution to work based on the number of resources you've got in your cluster. If you've got content like this, share it. We can help you write it if you'd like us to. Particularly for me, I think some data specific, domain specific content would be really helpful, like if you're working in networking or you're working with clickstream data, especially stuff that's, say, geared towards web development or to BI. Let's all write more together. If you're a committer or you're a code writer, let's start circulating ideas that would help people make that log trawling effort less intense. Maybe we'll start surfacing more in the Druid console, or maybe putting stuff inside the log that tells people where the ingestion job has got to in its life cycle. And finally, make pretty slides. They won't be as good as mine, but you can try. Do think about speaking, but not just speaking on a stage, That means joining in community meetups. If you're a leader of a Druid meetup, or maybe you lead a team that uses Druid, please think about having focus groups on ingestion, maybe contributing some kind of hackathon code or some helpful community content. This is some stuff we've come up with. Matt and I are working on some walkthroughs on particular types of data. I'm working on some stuff around schema design. We've also got this kind of skills framework thing we're playing with about the kind of skills you might need to use if you're doing a Druid-based pipeline. And that, ladies and gentlemen, is the end of my presentation. And I should now open the floor for questions. Thank you.